Hi guys. So of course, no class today, but here we go. The next 4 sections are all word problems. So I'm going to split it up into 2 videos. I'm going to have section 2.5, which is an introduction to problem solving. We've got the cute little problems, and then section 2.6, which is formulas and problem solving, which means that we're going to be using probably a lot of geometry ideas to do those. So just bear with me. I've had some issues with Zoom. I don't know what's going on with Zoom. I've recorded stuff for another class and I got cut off. So if I end up getting cut off, this may end up being put into a bunch of little mini videos, and that's okay too. So the first thing that we are going to do is we're going to look at the box on page 111 in your ebook. Here it is. So the first thing that we want to talk about is this idea of our general strategy for problem solving. So this is what we are going to use for the next 4 sections to be able to do these problems. So number 1, you want to make sure that you understand the problem, understand what it's asking for. So during this step, become comfortable with the problem. Some ways of doing this are to read and reread the problem. Choose a variable to represent the unknown value. Construct a drawing whenever possible, and then propose a solution and check. Pay careful attention to how you check your proposed solutions. This will help when writing an equation to the model to model the problem. Number 2, translate the problem into an equation. Number 3, solve it. And number 4, interpret the results. Check and make sure that your answer makes sense. If you are talking about the length of a board and you get a negative number for the length of a board, something is wrong. You need to go back and check your math. Okay. So let's just jump in. We're just going to do a bunch of examples of word problems here. So we're going to go to page 117. And yeah, here we go. So what you may be seeing, some of these problems, and I'm flipping my screen so it's easier to write on it. Some of these problems I may have to go to the whiteboard just because we don't have enough room. So you're probably going to want to make sure that you have your ebook open as I'm reading through these, just so you can look at the problems as we go. The first one that we are going to do is number 2. The difference of 3 times the number and 1 is the same as twice the number, and we are asked to find the number. This is definitely one that I'm going to pull up on my whiteboard, and I am going to have to pull up the book just so I can keep rereading the problem to you as well. So I've got my paper copy of my book. So let's go to the whiteboard. And this is a process. We got to stop share, and then we've got to reshare, and I got to reshare a whiteboard. There we go. Okay, the difference of 3 times the number and 1 is the same as twice the number. Find the number. Oh, come on. No, we're not doing this. My pen has decided that it does not want to connect to my computer all of a sudden. Come on. You would think that I wouldn't have issues with technology outside of the classroom, but obviously we're wrong. Okay. Oh, it made a movement. Let's see here. Yay! Oh, we're so good here. Okay, so number 2. The difference of 3 times the number and x is the same as twice the number. Find the number. So first thing we need to do is we're asked to find the number, right? We don't know what that number is. So I'm going to call that number, we'll start out with the classic x. So x is going to be equal to a number. So the difference of 3 times the number, let's start there. So the difference of 3 times the number and 1. Okay, the difference of 3 times the number and 1. So 3 times the number is going to be 3x. And of course, we know difference means subtract. So I'm going to do 3x minus 1. And then it goes on to say is. In math, the word is means equals. So we got 3x minus 1 equals twice the number. So twice is a form of multiplication. It means that you're multiplying by 2. So I'm going to multiply 2 times x. Once we get to this point, it's just a matter of working it out. Now, because we spent so much time in class going over how to solve equations, you're going to kind of see me breeze through these steps. If some of this doesn't make sense, you need to email me and let me know. So I'm just going to kind of quickly go through the solving of this. So what I'm going to do is I'm going to subtract 3x from both sides. I get -1 equals -x. I'm going to divide both sides by -1. So we end up with x equals 1. So my number that makes number 2 correct is x equals 1. All right, cool. We survived our first word problem. We've only got like, I don't know, 4 million left. We got a bunch. So let me close this. I'm going to stop share. Let's go to the ebook again. We're going to look at number 6. So number 6, I might be able to squeeze number 6 in this little space here. Come back. So number 6, 5 times the sum of a number and -1 is the same as 6 times the difference of a number and 5. Find the number. Woo. So notice here where it says 5 times the sum. So 5 times the sum. So the first thing that I need to do is find the sum of a number and -1. So the sum of a number and -1. And well, we don't know our number, right? So let's call our number. Let's get crazy. Let's let our number be equal to n. My goodness, I've pulled out all the stops. So our number is going to be n. So we've got the sum of a number, which is n, plus -1. That's the sum. So now we're going to do 5 times that sum. So this needs to be in parentheses times a 5. Is the same as. So is the same as is going to mean equals. So it equals 6 times the difference. Now see how it's 6 times the difference? So you need to go find the difference. So 6 times the difference of a number and 5. So the difference of a number and 5 is going to be n minus 5. And I'm going to multiply that by 6. So our classic problem here, we did a bunch of these last time. We've got parentheses. So now I'm going to go through this process of solving. So the first thing that I'm going to do is I'm going to distribute out my 5 and my 6 to everything. So I'm going to get 5n plus -5 is the same thing as -5. And then I'm going to have 6n minus 30 when I distribute out. And guys, I'm running out of room really quickly. I just wanted us to be able to read the word problem at the same time. So I'm going to do some math here in my head. Because you have the ability to pause this video, pause it, go through and work it, and then we'll compare answers here. So I'm going to subtract 5n from both sides and add 30 to both sides. So I'm going to have 25 equals n. So I'm done. There we go. 25 is equal to n. So that's my number. And 25, I mean, that sounds good, because if you do 25 minus 1, you get 24. And then if we do 25 minus 5, we get 30, or no, we get 20 times 6. Yeah, I like it. I like it. All right, good. So let me clear this out. Did my video just stop recording? Let's check. No, we're still recording. We're good. We're good. I'm paranoid now. I recorded an hour and 20-minute video and I got 20 minutes of it. So you're going to see me sporadically check this. Let's go on and look at number, let's do 10. So number 10, a 46-foot piece of rope is cut into 3 pieces so that the second piece is 3 times as long as the first piece, and the third piece is 2 feet more than 7 times the length of the first piece. Find the lengths of the pieces. Now, they are so nice to us. They already have this set up. We just need to do a little bit of work. But I want you to understand how they did this, because here's what's going to happen. They're going to give us this problem without giving us this beautiful picture on number 10. So they've cut it into 3 pieces. They called the first piece X. We don't know the first piece. They called it X. The second piece was 3 times as long as the first piece. So that's how they got 3x, right? That's how 3x come about. And then the third piece is 2 feet more than 7 times the length of the first piece. So that's how they got that part. So just keep that in mind as we're going through and working this. So it's a 46-foot piece of rope. So that means all together, this rope is 46 feet long. So when I say together, or I could change the word together to be total. The total length of this rope is 46 feet long. So that means that if I take the first piece, which is X, and I add it to the second piece, which is 3X, and I add that to the third piece, which is this lovely 2 plus 7X. And I can put parentheses around the 3X and the 2 plus 7X just to say, hey, this goes together and this goes together. It doesn't matter. Parentheses aren't going to do anything. That needs to equal to be 46. So if I combine like terms here, X plus 3X plus 7X is going to be 11X plus 2 equals 46. I'm going to subtract 2 from both sides. So I'm going to get 11X equals 44. And then I'm going to divide by 11. So X is going to be equal to 4. Okay, I know I skipped that step. I want you to pause the video, work through it, make sure you get the same thing that I do, and then start it back up. I need an eraser here. I need to erase this and this. Okay. There's my pen again. Now, I'm not done because notice how it says find the lengths of the pieces. Come on, where's my annotate menu? So I need to go through and actually find the length of each one of these pieces, but as long as I know what X is, I'm good to go. So this piece right here, this first piece, is going to be 4 feet. Because that piece was considered to be X, so X is 4 feet. The second piece, you see how it's 3 times X? This piece is going to be 3 times. Now, what did we say X was? X was 4, so this is going to be 3 times 4. So we get 12. So we get 12 feet is the second piece. So there's the first piece, 4 feet. Second piece is 12 feet. The last piece here was 2 plus 7X. So I'm going to have 2 plus, well, X again was 4 feet. So I'm going to have 2 plus 7 times 4. So I'm going to have 2 plus 28. 2 plus 28 is going to give me 30. So this is going to be 30 feet. So there's the lengths of each one of my pieces. We've got 4 feet. We've got 12 feet. We've got 30 feet. We can check this right quick. 30 plus 12 is going to give me 42 feet. And then if I add that last 4 there, that's going to give me a total of 46 feet. So I feel really good about what we just did here. So that's number 10. Let me clear this out. Let's go on and look at what do I want to do next? There's so many good ones to choose from. Find the value of X. Okay, so let's look at 14. So the directions for 13 and 14, use each table to find the value of X, then write a sentence to explain in words the meaning and the value of X. So the vast majority of movie screens in the United States in 2014 were digital. So they're telling me the analog was X. Digital is 39,771 more than X. This is confusing because it's wrote more than X, but we need to write an algebraic expression that explains this out. And then the total screens is going to be 43,265. So the first thing I'm going to do is let's jump in here and I'm going to clean up this 39,771 more than X. More than means add, right? So we're going to do 39,000. And guys, my pen it does not want to write 3s and 9s. So 39,771 more than means plus X. You need both of that. You need the number and the plus X to make this work. So now we know that if we take analog and we add it to digital, that's going to give me the total amount of screens I've got. And that's exactly what I'm going to do. I'm going to take my analog, which was X, and I'm going to add it to my digital, which is this whole entire thing here. So 39,771 plus X, and that needs to be equal to 43,265. 43,265. So now to solve this, I'm going to combine my like terms. So I'm going to put my X and my X together, which is going to give me 2X. So I've got 2X plus 39,771. And that needs to be equal to, we said 43,625. So to work this out, I'm going to subtract 39,771 from both sides. This is the only calculator I can get a hold of right now. So we're going to do 43,625 minus 39,771. And then I'm going to divide that by 2. So hopefully you're working this out on your piece of paper as we go. I'm going to divide that by 2. And if I divide that by 2, that's going to give me 1,927. So what that tells me, let me erase some stuff here so I've got room to write. Analog screens is 1,927. What happened here? I had a pen, it's not writing. There we go. 1,927 screens. To get the digital, remember, I'm going to do, it's got to be 39,771 more than X. So I'm going to take X, which is 1,927, and I'm going to add to it 1,927. Add to it 39,771. And that is going to give me a total of here 41,698. So there's my two answers. So do you see how we're getting 2 answers? But we're trying to put everything in terms of X. Because what a lot of people want to do is you remember when you were in algebra and you'd have like an X and a Y. Like if you had 2 unknowns, you'd have an X and a Y. We don't know enough math right now to be able to do that, because for every unknown or every variable that you introduce into a problem, you have to have that many equations to do that problem. So on this one, if I'd had an X and a Y, I would have had to have had 2 sets of equations to be able to work that. And we don't know how to do it. So we're heading towards that. Okay, so that was number 14. Let me clear my screen. What else can we do? Because we talked about this last time, so I'm going to hold off on that. If you've got questions about that, you're more than welcome to ask me on Tuesday. I'm gonna skip that one for now, just because I want to keep heading towards the word problems. And we're going to pick up some of that in this stuff. So let's look at number 26. So number 26, the room numbers of 2 adjacent classrooms are 2 consecutive even numbers. If their sum is 654, find the classroom. Let me pull up a whiteboard. All right, so on my whiteboard here, let me reread the problems. Number 26. The room numbers of 2 adjacent classrooms are 2 consecutive even numbers. So we talked about examples of consecutive even numbers last time. For instance, consecutive even numbers could be like 6 and 8, or 10 and 12, or 22 and 24. So it's just 2 even numbers that go back to back. So let me make a note here. We've got our first class and we got our second class. All right. So I don't know the number to my first class, so let's just call it, let's get crazy. I'm gonna call it C. C is the number to my first class. And then I know my second class is the second consecutive even integer. So let's say, for instance, one class was 22. How do I get from 22 to the next consecutive even integer would be 24? So to go from 22 to 24, I would have to add 2 to 22, right? This is what we talked about in class. So my second class will end up being C plus 2. And yes, you have to have the 2. You have to say, I'm adding 2 back to my starting point, which in this case was C. So whatever our starting point ends up being. Now, we know that the sum of the two classroom numbers is 654. So I'm going to take C, and I'm going to add it to, so that's my first class. I'm going to add it to my second class, which is C plus 2. Now, again, we don't need the parentheses. I just put them in there to really signify that's our second classroom number. That's going to be 654. So now I can combine like terms. So I'm going to have 2C plus 2 equals 654. I'm going to subtract 2 from both sides. I'm going to get 2C equals 652. And then I'm going to divide both sides by 2. So we end up with C equals, I don't know, let's find out. So 652 divided by 2 is 326. So my first classroom is going to be 326. And if my first classroom is 326, I add 2 to that number to get to the second classroom, which is going to be 328. So there are my two classroom numbers. Cool. So it's taking, we've already done this part of setting up C and C plus 2. We've done that. We're just taking it a step further now, and we're learning how to solve with that. Okay, so let's look at, I think I want to do number 30. Yeah, let's do number 30. Close this. I want to stop share. Start share again. Well, give me a second. I'm having some issues. Okay, number 30. The largest meteorite in the world is the Hoba West, located in Namibia. It weighs, or its weight is 3 times the weight of the Armonti meteorite located in Outer Mongolia. If the sum of their weights is 88 tons, find the weight of each. Oh, I can't speak today. All right. Need my pen. Come on. There we go. So the largest meteorite in the world is the Hoba West. It weighs 3 times the weight of the Armonti meteorite. So here's what happens. We're talking about 2 different meteorites, right? We've got the Hoba West. Hoba West. And then we also have the Armonti. Now, so we know one of them has to be called X, or the weight. So here's what happens. It turns out that the Hoba West is based off of the weight of the Armonti. So this is going to tell you which one needs to be called X. So because the Hoba West is 3 times the weight of the Armonti, we don't know the weight of the Armonti. So I'm going to call the weight of the Armonti X. So its weight is X. That means that the Hoba West is 3 times that weight. Well, what does 3 times mean? Well, let's multiply that by 3. So we got 3x. So the sum of their weights is 88 tons. So if Armonte weighs X, Hobo West weighs 3X, then if I add those two things together, right, because that's what the sum means, we're adding, I should have, so we got X plus 3X equals 88. So if I combine like terms on the left side, I'm going to have 4X equals 88. I'm going to divide both sides by 4, so I get X equals 22. So that tells me the weight of the Armonte. The Armonte weighs 22, and I believe this is tons, right? It's 22 tons. So the Hobo West is 3 times that amount. So all I have to do is plug 22 in for X. I'm going to have 3 times 22, which in this case is going to be 66 tons. So there we go. Guys, again, your inclination is to go through and try to use 2 different variables. Do not do that. If you do that, you're lost. You can't do anything with the problem. So you want to make sure that one's based off the other. So the way that I always read this is I figure out, okay, which one is, if I call one X, can I figure out what the other one's going to be by doing some type of math to it? So I always figure out which one's my most basic one, which one's either the smallest or the largest, just depending on how the question's worded. Okay, let's do another example. So that was number 30. I want to do, I don't know, let's look. What we got? And unfortunately, guys, and this is where it gets a little bit frustrating. It doesn't matter how many of these problems that I do and I show you, I could do a million examples. But until you stop and you sit down and you try to figure out how to do the problem, it may or may not help you to have a million examples. So it's really going to depend on you sitting down and practicing these sections to be able to do this. So what I'm actually going to encourage you to do from here on out is before I jump in and do the problem, I would actually pause the video. You try to work the problem out on your own and then come back and compare it to what I did and see how you did here. I think we should let's do number 38. So quadrilateral is a polygon with 4 sides. The sum of the measures of the 4 angles in a quadrilateral is 360 degrees. If the measures of the angles of a quadrilateral are consecutive odd integers, find the measures. Okay, so we're following our steps here that we talked about in the book. We're reading it. We're trying to understand what's going on. So quadrilateral is a polygon with 4 sides. The sum of the measures of the 4 angles. So we're talking about these things, right? Where's my annotate? Talking about these measurements in here, right? So all of those measurements are going to add up to be 360 degrees. And that's not random. That actually is the case. It's always 360 degrees in a quadrilateral. In a triangle, it's 180 degrees. If the measures of the angles of a quadrilateral are consecutive odd integers, find the measures. Consecutive odd integers. So an example of consecutive odd integers would be like, I don't know, 3, 5, 7, 9. So this is very similar to the problem that we did in class the other day, where we set up our consecutive even integers. And we talked about how consecutive even and odd integers work the same. So let me clear this out. I'm going to go to the whiteboard just so I have more room to work. I wish there was a nice way to do that instead of having to hit stop share and reshare, and I get these weird pictures of myself that I don't like. Okay. So let me draw some random quadrilateral. There we go. There's my quadrilateral. So I've got 3 or 4 angles here. And we're saying that they're consecutive odd integers. So I'm just going to start. I'm going to say that my first angle is X. Cool. So to get from X to the next one, remember, so how do I go from 3 to 5? Well, you have to add 2 to 3, right? So to get to the next one, it's going to be X plus 6. All right. And then because I have to base it off the previous, or, I have to kind of go back to that original one. My next one would be like 7 if I was doing a what if scenario here. So my next one would be 7. So how do you get from 3 to 7? Well, you add 4 back to 3. And then finally, how do I get to the last one? Well, that's going to be x plus 6. So I've got my 4 consecutive angles set up. And here's what I know about those angles. If we add them up, some of the measures of the 4 angles are 360 degrees. So if I take my first angle, which was x, and I add to it my second angle, which was x plus 2, and I add to it my third angle, which was x plus 4, and I add to it my fourth angle, which was x plus 6, that's going to be equal to 360 degrees. Okay, so now we want to go through and combine like terms. So x plus x plus x plus x is going to give me 4x. And then 2 and a 6 is going to give me, 2, a 6, and a 4, sorry. It's going to give me 10, 12? Now, like I said, we did this before, right? We actually got 4x plus 12 when I was looking at 4 consecutive integers, or 4 consecutive even integers. Okay, so let's do 360 minus 12 on both sides. Whoop. Those cancel, so my 4x equals. And just because I don't trust my math today, 360 minus 12, because I don't have yours there to yell at me, is 348. So now I'm going to take and divide both sides by 4. So I end up with x equals, 348 divided by 4 is 87. So we end up with 87 degrees. So that's my first angle, right? So this angle here is 87 degrees. So my next angle would be x plus 2. So 87 plus 2, which would be 89. And then if we add 2 more, or add 4 to the original, that's going to give me 91. And then my last one, of course, is going to be 93 degrees. Cool. So that's using basically like 2 sections worth of math that we practiced setting this up and actually seeing a problem working with these consecutive even and consecutive odd integers. So that's really awesome. Okay, what else? What else do I see here? So that was number 38. Let's do, I'm looking for some cool stuff here, some stuff that we've not looked at. Let's do number 44. Let me clear all the drawings. Let's stop share. And then we're going to reshare my book. So number 44, 2 angles are complementary if their sum is 90 degrees. We know that. A larger angle measures 3 degrees less than twice the measure of a smaller angle. If x represents the measure of the smaller angle and these 2 angles are complementary, find the measure of each angle. Okay, so they've given us our x. That's great. So they've given us our x, but then they say a larger angle measures 3 degrees less than twice the measure of a smaller angle. So our smaller angle is x. So how do I set up 3 degrees less than twice the measure? So twice the measure would be 2x, right? But I have 2x and then 3 degrees less than that. So this would be 2x minus 3. Okay, cool. So I've got my 2 angles now. And I know that these 2 angles are complementary, so their sum is 90 degrees. So if I take x and I add to it, add 2x minus 3, that's going to be equal to 90. So x plus 2x is 3x. combining my like terms. So now let's go through and I'm going to add 3 to both sides. So if I add 3 to both sides, I'm running out of room. If I add 3 to both sides, it's going to cancel out on the left side and I'm going to have 93 on the right side. I need to divide both sides by 3. So if I divide 93 by 3, I'm going to get 31. And of course, if you divide 3 by 3, you get 1. So it just kind of cancels out. So we get x is equal to 31. So this angle is 31 degrees. This angle here is going to be 2 times 31. It's a degree symbol. My goodness, this pen does not want to write little itty bitty things. So if I do 2 times 31, that's going to give me 62, and 62 minus 3 is going to be 59 degrees. So there's my 2 angle measurements. And it's good. If I do 31 plus 59, I get 90, which makes me feel really great, because if it doesn't add up to 90, I have done something horribly, horribly wrong. Okay. I'm just kind of looking through here and seeing, like I said, we're going to do lots of practice with this one on Tuesday when you get to do your labs. I want to do one, I think, with fractions, and then that's probably, let me see, what else we got here? Okay, I'm going to do one of these. I think I'm going to do 38. And then I'm going to do 58, and that'll be all in this section. Because like I said, I could do an example of every single one of these problems, but until you sit down and try it on your own, it may or may not make sense. Okay, so number 48, if 3/4 is added to 3 times a number, the result is 1/2 subtracted from twice the number. Wow. Find the number. I'm going to try to do it on this page because it's so much easier to read it and see me write it down at the same time. So if 3/4 is added to 3 times the number. So first thing I need to do is find 3 times the number. So 3 times the number is 3x. And if 3/4 is added to that, so this must be 3/4 plus 3x. Okay, cool. The result is, now result is means equal. So I'm going to have 3/4 plus 3x equals 1/2 subtracted from, so that changes the order, twice the number. So twice the number is going to be 2x, right? And I really should have said, oh, our number is going to be x. So we've got 2x. We're going to subtract 1/2 from it, so 2x minus 1/2. My mother's dogs are going to list it because my mother's house is the only place quiet enough for me to do these videos without having screaming children in the background. So yeah, I apologize. Okay, so let me take this to a whiteboard so we can actually see some stuff going on, because I'm going to clear my fractions out to practice that skill again. So I'm going to stop my share. I'm going to pull up a whiteboard. Here's my whiteboard. There it is. All right, so let me write this out here. We said that we're going to have 3/4 plus, and then we said 3 times the number, so 3x equals, and then we had twice the number minus 1/2. I think my voice is trying to go. Okay, let's clear our fractions. I've got so many pretty colors to choose from. Let's do red. So my LCD is going to be the common denominator for everything. So notice this is really sitting over a 1 and a 1. So it's not going to do a lot. So I'm literally looking for my LCD between 4 and 2. My LCD between 4 and 2 is going to be 4. So I'm going to multiply every single term that I see by 4. And if I have done this process correctly, I'm going to see denominators cancel out. So here, that 4 and that 4 is gone. becomes a 1 and a 1. Nothing's going to cancel out with a 3x and 4 because it wasn't a fraction. Same thing with the 4 and the 2x. It wasn't a fraction. Nothing's going to cancel out. However, you see this 2 and the 4 on the very end. 2 and 4 is both divisible by 2. So that becomes a 1 and a 2. So now I'm going to multiply straight across. Notice how everything's got a 1 across the bottom. I don't need to keep it. So 1 times 3 is going to be 3. Plus 4 times 3x is going to be 12x. Equals 4 times 2x is 8x. And we've got minus 1 times 2, which is 2. This statement says the very same thing as the one with the fractions. It's just we probably would much rather work this statement out. So here I'm going to subtract 8x from both sides. And while I'm at it, because I'm going to run out of room underneath this equal sign, I'm going to go ahead and move my 3 to the other side. So those 3's cancel out. So 12x minus 8x is 4x. We got 4x equals negative 2 minus 3 is negative 5. I'm going to divide both sides by 4 now. So we end up with x equals negative 5/4. Awesome. Love it when we get a fractional answer, but I'm sure you do too. Okay. One more problem on this section, and then I'll post a video for the other section. So I'm going to clear this out. Stop share. So I can reshare all over again. That's all I get done. Number 58. A 48-foot long piece of cable wire is to be cut into 3 pieces so that the second piece is 5 times as long as the first piece, and the third piece is 6 times as long as the first piece. If X represents the length of the first piece, find the lengths of all 3 pieces. This looks so confusing. We're going to draw a picture. So anytime I can, I'm going to draw a picture because pictures make things make sense. So let's see here. Do a different color. Let's do orange. Look at that. Okay, so I've got a piece of wire here, cable wire. And I'm going to slice it into 3 pieces. So it would be lovely if these 3 pieces were equal, but you know what? They're not going to be. So here's where I'm slicing it like that. So we know that the total length of the cable is 48 feet. We're cutting it into 3 pieces, which we've done. So the second piece is 5 times as long as the first piece. All right. And the third piece is 6 times as long as the first piece. So if X represents the length of the first piece, so they're already telling us that the first piece is X. So I can just go ahead and slap me an X right there. So that the length of that one is X. Okay, let's talk about the second piece. It's 5 times as long as the first piece. So do you see how it's like we're doing like many little translation sentences like multiple times to get this? That's all we're doing. So the second piece is going to be 5 times as long as the first. So 5 times as long as the first would be 5x. And then the third piece is 6 times as long as the first piece. So 6 times would be 6x. And then we know it's a 48-foot long piece of cable. So that must mean that I need to go through and actually I'm going to have to come over here on the other side of the, I guess this is the Empire State Building over here in the Pentagon. X plus 5x plus, oh man, that doesn't even remotely look like a plus, does it? This pen does not want to write pluses. Plus 5x plus 6x. That one again. And that's going to be equal to 48. So if I do x plus 5x, now remember this has got a 1. So 1x plus 5x is 6x, and 6x plus another 6x is going to be 12x. So we get 12x equals 48. To solve this, I'm going to divide both sides by 12. And if I do that, I'm going to get x equals 4. So we got x equals 4. So my first piece is going to be 4 feet. My second piece is going to be 4 times 5, right? Because it's 5x, so 4 times 5, which is 20 feet. And my third piece is going to be 6 times 4, which is going to be 24 feet. And if you want to check this right quick, we can add this up. 4 plus 20 is 24. 24 plus 24 is a total of 48. We did great. All right, guys, that's the first section. I would love to say the next section is easier, but again, it's all word problems, and I know how you feel about those. So I'll post another video for the second section.